Okay, hello everyone. Hope everyone is still doing okay. So far we're in the middle of our last unit, which is solving quadratics. And let's just go ahead and kind of do a quick review of everything we've done so far in the unit. So we're solving quadratics, and the first method we saw was solving by graphing. Or I think that's our second method, but the idea is if we're given an equation, we want to graph both sides of the equation. So let's say we have a quadratic, we have a parabola, and then let's say we have a line that goes like this. And then the key is to solve it, you want to look for the points of intersection. So in this case, our solutions will be here and here. And then we only want the x values. So then those will be our two x values. Those will be our solutions. Now, the negative of this method, the downside is sometimes these intersection points could be fractions. And it's very hard to tell what those numbers are if the numbers are fractions. Okay, so let's say a con, right? Pros and cons. The con will be fraction or decimals. And then let's go to our next method, will be factoring. So this we did during our last unit, actually, when we did polynomials. So factoring, let's say I have an equation like x squared minus x minus 20 equals 0. And the idea here is you want to find two numbers that add up to -1 and multiply to -20. And in this case, this is factorable. We can have x minus 5x plus 4 equals 0, and then solve for x. And then from there, it's kind of pretty straightforward. We have x equals 5 or -4. And then the downside of this, the con, is, of course, sometimes we're given something that's not factorable. Okay, so what if something is not factorable? And we've seen those equations before, right? So two numbers that add up to some number and multiply to another, but those two numbers don't exist. Okay, so if it's not factorable, then we can't solve by factoring. And then the last method that we saw so far is solving by undoing. So that was, for example, equation like, let's say 2 times x plus 1 squared plus 1 is equal to, let's say, 21. Okay, and the idea here is to isolate the square. So we want to isolate this guy right over here, isolate the x plus 1 squared. So first we'll subtract 1 on both sides and then divide by 2. And then the downside here will be our equation must be in this form. So we have to have an equation that must be in this form. In other words, we must have the square somewhere in the equation. We have to have, let's say, x plus 1 squared or 2x plus 5 squared. Okay, so we've seen each of these methods already, and now and we see what their downsides are. So now let's see what if we're given an equation like so, like x squared, let's say, plus 6x, and then let's say I want to do let's say minus 11 equal to 0. Okay, so then let's go ahead and see if our methods that we saw so far will work. So solving by graphing, well, first of all, we're not given a graph. And then in this case, if we do graph it, we're actually going to run into this problem right here. We're going to run into some fractions and decimals problem where it's hard to tell what the solution is. So graphing wouldn't really work. Okay, let's try factoring. In this case, can we find two numbers that add up to 6 and multiply to -11? Can we find two numbers that are like that? And in this case, I think the answer is no, right? We can't have two numbers that add up to 6 but multiply to -11. So that's no good either. How about our last method? Can we solve this by undoing? In other words, can we find the x by itself where it's squared? And in this case, the answer is no, right? Because here's x squared. Here's x squared, but we also have an x over here, right? So here we have x in two places, and so we cannot use solving by undoing, right? So undoing, you have to have the x in one place and it's squared, so right over here. But here we see the x in two places. Okay, so right now, as is, we cannot solve by undoing just yet. Okay, so none of our methods that we learned so far would actually work. Okay, so which is why we have this next method, and it's called, as I wrote up top here, completing the square. Okay, so that's what we use, is solving by completing the square. So that's our next method, complete the square. Okay, but before I actually solve this equation, I'm actually going to talk about what that is, what complete the square is. So we're actually going to come back to this right over here. So let me box this. We'll come back to this at the end of the video to see how we can actually solve this using a new method called complete the square. Okay, so let's go ahead and talk about what that is. So what complete the square is turning an equation or an expression from a form that we don't like into a method that into a form that we can solve by undoing. Okay, so we want to turn our equation into a new equation that we can then solve by undoing. Okay, so let's take a look at some examples. So let's say I have on the left side a squared plus 8a. Okay, so again, here we see the a in two places. We have an a squared and an a here, but that's not what I want if I want to solve by undoing. Okay, I just want the a in one place and have that be squared. So I want to end up with something that looks like this, right? Where we have, that looks pretty bad, so let me erase that. I want to have a in a parentheses and then squared. Okay, so now the question becomes, what number do I need to add here in the blank to get this form? Okay, so that's the question. So let's take a look. So let's say we have, or in this case, I'm going to just tell you the answer, and then let's see why that's true. Okay, so in this case, our number is going to be 16. And why is the number going to be 16? Well, so if I have this expression now, a squared plus 8a plus 16, this is something we can actually factor, right? So here we want two numbers that add up to 8 and multiply to 16. What are my two numbers? Well, that's going to be 4 and 4. So then I can write this as a plus 4 times a plus 4, which I can then write as a plus 4 squared. Okay, so now this is an expression that I like. Okay, so I can use this if I'm trying to do solving by undoing. Okay, so right now I'm not solving just yet, but if I have something in this form where it's a plus 4 squared, I can use that to help me to do solving by undoing. Okay, so now the question is, how did I come up with this number? How do I know that the number is 16? Okay, and I think you're all going to see a pattern as we do more of these examples. Okay, so let's just go ahead and do a few more. So now let's say I have p squared minus 12p plus something, and then I want to write that as p in parentheses and then squared. Once again, the problem here is I can't solve by undoing just yet because I have the p in two places. Okay, so what I really want is I want to be able to factor this such that these two factors are the same, right? So then I can write it in this form. Well, in this case, this is minus 12p, and what number do we think we should add on this line here to get what we want down here? In this case, it's going to be plus 36. Okay, why is that? Well, because if we have p squared minus 12p plus 36, we can factor this as two numbers that add up to negative 12 and multiply to 36. We can write that as p minus 6 times p minus 6. And then we can write that as p minus 6 squared. Okay, so that's why this method is called completing the square, is we want to complete it such that we end up with a square as one expression multiplied by itself, which is why it's called complete the square. Okay, so let's go ahead and just do a few more just to see if we can get the pattern. Again, we have the variable on two separate cases, so we need to first put a number such that we can write it in this form, and then we can write it in this form. Okay, so in this case, we have s squared minus 18s plus blank. And then let's figure out what number we should add here. Okay, so the general pattern, actually, I'm actually going to do it in a different color. So the general pattern is what number we add here depends on this value right here, depends on our b value, right? So remember, in the standard form is a squared plus bx plus c. Okay, and here's what we want to, here's how we can figure out what number to add. Is we always want to take the b value and divide it by 2 and then square it. Okay, so you take the b value and you divide it by 2 and then you square it. And then, so let's take a look at the examples that we did so far, right? So over here we have 8 as our b value. So we take 8 and we divide it by 2 and then we square it. Well, 8 divided by 2 is 4, squared is 16. Okay, and that's how we got the 16 to be underlined there. And then we can then factor as a plus 4 squared. Over here, our b value is negative 12. And then we want to divide by 2 and then square it. Negative 12 divided by 2 is negative 6. Negative 6 squared is a positive 36. And then that's where this 36 came from. So in this case, our b value is negative 18 divided by 2. Square it. Negative 18 divided by 2 is negative 9. Square it is positive 81. So we want to plus 81 in this case. Okay, and then let's see how we can factor it. Well, we want two numbers that add up to negative 18 and multiply to 81. In this case, will be s minus 9 and s minus 9. So then we can write this as s minus 9 squared. Okay, which is what we want and what we mean by complete the square. Okay, so this right here is kind of the magical formula, the one that's highlighted, to completing the square. Okay, so you take your b value, divide it by 2, and then square it. Okay, so let's go ahead and try just 2 more to see how this works. And then if you like, you can actually pause the video right now and then try these 2. And again, the goal is to complete the square. Okay, so hopefully you've given these a try. So let's take a look. So here we want to, again, write it in this form, factor it in this form so that we can write it as a square, complete the square. Here, what's our b value? B value is 24. So we'll do 24 divided by 2 and then square it. So that's 12 squared is 144. You can use a calculator to help you with that step. So then we need to add 144 here. So then we can factor this as x plus 12 times x plus 12. Two numbers that add to 24 and times to 144, which then we can write as x plus 12 squared. Okay, and then one last one. This one is actually a bit trickier because here, what's our b value? B is negative 3 divided by 2 squared. Okay, the reason why it's a bit tricky is because if we do negative 3 over 2, you're actually going to get a decimal, right? You actually get negative 1.5. But the idea is still the same. We can just do 1.5 squared, which again, you can use a calculator. And I think here you get 2.25. Okay, so 2.25. And then how can we factor this? Well, in this case, again, it's a bit different. It's a bit difficult with the decimal, but we're actually going to have minus 1.5 and minus 1.5, right? Those will add up to negative 3, but multiply to 2.25. So this example is not too common. You're not going to be completing the square with decimals too often. Most problems will do is with the ones that we saw up above with the whole numbers and integers. So this one you don't really have to worry about, but just to show that you can also complete the square if you have a decimal. Okay, so then let's actually go back to what we started at the beginning with this equation. Okay, so remember how I said I was going to come back to this equation. Okay, so x squared plus 6x minus 11 equals 0. Again, all the methods that we learned so far, graphing, factoring, undoing, those will not work. Okay, so what I'm going to do is let's rewrite this at the bottom. So x squared plus 6x minus 11 plus 6x minus 11 equal to 0. And we will actually talk more about this next time, but this is just kind of a preview of how we can use the method of completing the square to solve a problem like this. Okay, so here's what you want to do when you want to solve and complete the square. Okay, so here, let me move this down a little bit. So here we're solving by completing the square. Okay, so here's what you want to do. You want to move the number or the constant to the other side. Okay, so let's go ahead and move the number part to the other side. So then we get x squared plus 6x equals 11. Okay, again, we're not solving by factoring anymore because this cannot be factored. So then we're not gonna have the 0 on the other side. Let's go ahead and add the number. So let's add the 11 to the other side. And then we end up with something that looks like this. And then here's what I'm gonna do. Okay, I'm gonna leave some space. So I'm gonna rewrite it, but I'm gonna leave some space here. X squared plus 6x. So what we're gonna do here is we're gonna complete the square. Okay, so just like what we did up here, we wanna figure out what goes on this line here. So what goes on this line right over here by completing the square? Well, again, we'll take the b value. In this case, that's 6. So we'll do 6 divided by 2 squared. 6 divided by 2 is 3, squared is 9. So that's the number that I'm going to put here. I'm going to add 9 to the left-hand side, okay? But we can't just magically add 9 to one side of the equation, right? Whatever we do to one side, we must do to the other side, okay? So we have to have the plus 9 on the right-hand side as well, okay? And now, you may be wondering, why do we just do that? Why do we add 9 to both sides? Well, now I can factor the left-hand side, right? I can factor this as x plus 3 times x plus 3 is equal to, and we can add those two, that's 20. And now we can actually write it like this, right? This is x plus 3 squared equals 20. Now this equation we do know how to solve, right? We can solve this using undoing because the x plus 3 is squared, right? So how do we get rid of this squared? Well, now, again, there's something we did over the past couple of days. We can square root both sides. So then we get x plus 3 is equal to, make sure you have the plus or minus, that's always important, root 20. And then again, root 20, I think I can simplify this, root 4 times root 5, or 2 root 5. So then I get x plus 3 is equal to plus or minus 2 root 5. And now I'm ready to solve for x by subtracting 3. So I get x is equal to negative 3 plus or minus 2 root 5. Okay, so that's our method, our new method of solving by complete the square. Okay, so again, I'm going to talk a lot more about this next time, but the goal for today is just knowing how we can complete the square, how we can come up with this number, 2.25, or the 144, or the 81. And again, the idea is you want to add b over 2 squared.